Just a few things. And so, how many of you actually followed the instructions that I had online on campus about starting our studio and then how to get started with R? Did any of you do any of that?
We just did the 1+1 and then I entered.
Okay. So, but you played around a little
Yeah.
bit, right? In terms of structure, so I don't know if you can see that. So I created a folder on the desktop, and I just called it R workshop. Okay, and this is how I typically work. One of the things that's going to happen is if you do get into working in a structure, if you need something like R or Python, one thing that may happen is that you're going to have data that you're going to use, that you're going to analyze, and so on. That data is going to come from somewhere, right? It's going to be an original data set. Ideally, you do not want to touch that data, right? You want to feed that data into your program, and then you're going to do everything in your program without ever modifying that data, right? If everything else breaks, having the original data is going to be what is going to allow you to go back and figure out what happened, right? So you always want to keep your data intact. So I normally, for a project, so this would be, I'm thinking of this as a project right now. And so I created a folder for my project. In this case, my folder is R workshop. And I created 3 subfolders, one for the data, one for any output I produce. So if I'm making graphs and so on, I'm going to save them under output. And then one for scripts. So we're going to be writing code, right? We're not going to be kind of clicking around. We're going to be writing the instructions that we want the computer to follow. And to be able to run those instructions at any point, we're going to save them into a program, which we call a script. And so I tend to save my scripts under a scripts folder. So I keep everything separate. So if you downloaded the data, what I did in my case is I saved that file under the data folder. And again, if you downloaded it, chances are that it downloaded as an Excel file. I would open that Excel file and then resave, but choose a CSV file. And again, you can import Excel files into R. It just takes a little bit more work. Because one of the things with Excel files is that you may have multiple tabs, so you have to be more specific about what tab you want to install if you want to import and so on. Whereas a CSV file is going to be a single tab, so if you have the file, you know what you're going to import. Okay. I'm not going to spend time on cleaning. I did a little bit of cleaning ahead of time, just for the variables we needed, so that we can focus primarily on the actual graph. Okay. Now, one of the first things that we have to do in R is tell it where we're going to be working. So normally, I put this in instructions. So normally, let's say you open a Word document, right? You type in a Word document, and you go to save it. There's going to be some default location where the file is going to save. If you don't choose anything and you just say save this file, it's going to save it to some default location, right? When you're working in this manner with projects, you want to set that location yourself because that's where you're going to be working. So you want to make sure that the output you're producing is going to where you want it to be placed. So what I'm going to do first is I want to move our default location, our working directory, to my R workshop directory. So I'm much more knowledgeable of PCs than Macs. So I know exactly how to find a path on a PC. I did not know how to do it on a Mac, although I copied some instructions. So if you're on campus, you can go look at some instructions there. But essentially, on a PC, you just have to click on the bar, right? And if you click on the bar, it gives you a whole path. And in some cases, those can be fairly long, right? I have 2 last names and they're long and they stick them together. So my username is a very long name. And so in my case, this is under C, user, my name, desktop, R workshop, which is where I put that. So with that click, I'm going to do Control C, which allows me to copy that path. And now I'm gonna switch over to our R Studio. And the first thing I'm gonna do is I'm gonna set that as our working directory. So we're gonna use a function, and the function is a function that sets the working directory. So set WD for working directory, open parentheses, open quotation marks, and paste that at. Okay? And for some reason, Windows by default chooses backslashes, and that's a problem because for a lot of programming stuff, the backslash is an escape character that you would use for other things. And so I normally get in the habit of changing all of my slashes to forward slashes. If you're working on a Mac, Mac actually uses forward slashes by default, so you don't have to do this step. But in my case, I have to switch over to forward slashes. Now, before I hit enter, I want you to notice this is actually telling me where I am right now. If you look up at the top here, that's telling me what directory I'm in. And in my case, we just installed R Studio and it's in like the R default directory. When I do this, my working directory has now changed to where I told it to go, right? I changed the directory and it did. So now I'm in the right directory. Make sense? Mm-hmm. Any questions so far? All right. So what you see on the screen right now are three different panes, right? So R has this thing on the left is called the console. This is kind of like, this has a multitude of things where you can see what files you have. When you make plots, they're gonna show up here. And up here you have what they call the environment. So let's start with the console. On the console, you can do stuff interactive. And so I could go in and I could just type 1 plus 1 and hit enter. And what's going to happen is that R is going to calculate what 1 plus 1 does, and it's going to tell me the result is 2, right? We do 1 plus 1. Here's your operation. Here's the outcome of that operation, right? So in the console, you can do stuff interactively. And sometimes we do, right? If I'm just testing something, I may just do it on the console as I'm trying something out, some calculation or something, right? Now, as I mentioned at the beginning, one of the nice things about working in this kind of way is that we're going to write code, we're going to write scripts, and those scripts we can then rerun later to actually do stuff. The other thing that is nice about those scripts is that we can fix them, right? I can go in and I can realize where I made a mistake, right? Where did I do a wrong calculation, and I can fix that calculation. Which also means it's important when you do scripts that you write down what you're doing on those scripts, both for yourself or for anyone else who may pick up your script and do something with it. It's nice to be able to follow those steps. So I'm not sure we have to put in comments in the script. So the console is useful for like some quick calculations. For anything you want to keep, you probably want to write a script. Make sense? So we're going to be writing code. A few other things to say about that. Again, the beauty of it is you can fix it. Not only that, if your data changes in the future for some reason, you can still open that script and rerun it with the new data, right? And so let's say you're working at a place where you have to make the same graph every month for, let's say, sales, right? And in some months you have a few rows of sales, in other months you have hundreds of rows of sales. Your script will still be able to open that and run it, right? Yes.
Is there like any function in the console which we are writing in console? Are they saving if we save the file?
They are not getting saved, right? So there are some programs where everything you're doing is getting recorded somewhere. In the console, it's not. But one thing you can do is you can use your arrow app and you will scroll through whatever you type. And then you can use your arrow down and scroll the other way. So if I have 100 lines that have been written in the console, I can scroll my way up and find it. And then I can just hit enter. Make sense? So let us get into maybe one more thing I will tell. R is it's an object-oriented program. Okay? So most of what we do in R is creating objects of some sort, right? So maybe I wanted to store this calculation that I did, right? And so I could give that a name, and I'm going to call it X, as I did in the file also. And so I'm going to say X, and I'm going to assign to X the result of 1 plus 1. Okay. So how do I get the little assignment thing, which looks like an arrow? If you're on a PC, it's Alt minus at the same time. If you're on a Mac, I do not know, but that's something like command minus or something. So again, if I wrote X, I pushed Alt and minus at the same time, and then that little arrow, and then I do 1 plus 1. If I hit enter now, in my environment, I have a variable called X, and the value of the variable is 2. Okay. So a lot of the things that we do, most of the things that we do is create objects, and there are different types of objects, right? But most of what we do is create objects of some sort and then use those objects for something. Questions so far? All right. A couple more things. R has a lot of capabilities built in, but there are a lot of things that we may want to do that rely on packages that have been written separately to do things. One of the most popular packages is called the tidyverse, and I don't do anything without the tidyverse. Everything I do uses the tidyverse. It makes it much easier to manipulate data. It makes it much easier to make nice graphs and so on. So you have to load those packages if you don't have them already. And since this is a new installation, I'm guessing I may not have it, so I'm gonna try. So what you will do is you will type out the command library function, open parentheses, and then write the name of that function, of that package. And so I do not have the tidyverse. I started typing tidy and it doesn't show up, right? So I actually don't have the tidyverse on this machine. So I have to install that package. So how do you do that? You type install dot packages, and you can see it kind of come up there. Install packages. When you install a package, you have to use quotation marks around it. So inside the parentheses, quotation marks, and then tidyverse. And I'm going to hit enter. And this is going to go through a process where it's going to try to download a bunch of stuff. And it turns out that tidyverse requires a lot of additional supporting packages to come with it. And so right now it's looking for places to download the tidyverse. But then it's telling me, yes, I've installed all this different stuff that is required for the tidyverse. So if you don't have the tidyverse, do what I just did, right? Install packages. In parentheses, between quotation marks, you write tidyverse. And it may take a little bit, but we'll get there. So far, so good?
Yeah.
Yes.
One more question before like installing is there any examples when companies using R? Because mostly I was facing that in academic fields, people do researches, they use R. What about industries? You're saying like reports and data visualization.
Right. So I work occasionally on consulting with a firm, and they are heavily invested in it, right? And so there's a lot of, if it's sort of econ businessy, they're often using it. Now, R is primarily a statistical software. It can do a bunch of other stuff, but it's primarily about statistics. Python is probably more broadly used if you're doing more general programming. Now, R Studio, the name is kind of deceiving because they actually allow you to write Python as well. So you could write Python scripts in R Studio. And that's something that they're building out more and more, is the capability of using Python within R Studio. So if you're comfortable with using R Studio, then you can even combine two. So that's one thing I wanted to point out about working with scripts. At the end of this, regardless of how far we get, I'm gonna have a script that I can post in Canvas, and each one of you can open that script and go step by step and figure out what I did if you missed it when I did it here, right? You will be able to open that script and change things on that script, which is the way that many of us learn this stuff. We take something that somebody did and we tweak something to kind of see what happens when we make them, right? And so that's one of the beauties of this, is that you're actually going to have a set of instructions, if you will, in that script that you can follow. All right, so if my installation of the tidyverse worked out, when I hit library and I type tidyverse, this time without quotation marks, then it's going to tell me that the library is installed, right? It's going to tell me that it's there. And so by calling that library, it is enabling the library in my work session. Now, a couple of things, yeah.
And you don't have to have the quotation marks around tidyverse this time.
Not anymore. So when you're installing packages, you have to have quotation marks. When you're calling the package, once you have it installed, you don't use quotation marks. And one thing you'll see is that it's telling me what other packages are being attached. So the tidyverse relies on a bunch of other stuff. One of the key ones for us is going to be this scatterplot tool, which is how we're going to make graphs. And they're much nicer graphs than what base R makes. The other thing that it shows you is this conflicts. And so what happens is there is a command in base R called filter. And what this is telling me is that the packages that we open have a command named filter. So because I enabled the tidyverse, that's the filter it's going to use. If I want to use the filter from the base R, I actually have to use stat : filter, so that it knows that I'm using the original filter command and not the tidyverse filter command. Now, this is important because there will be times when you're running a program where you want some stuff from your package, you want some stuff to be based on the original, or you may have multiple packages that have the same commands. And so you may have to tell it which package you want to use for that command. And so that's notation when you're doing that is package : command. And so in fact, you could not enable the tidyverse, and you could just type in tidyverse : filter every time you're going to use filter from tidyverse. But since I use everything tidyverse, then it's much easier to load that library in advance. Questions? So far, so good?
Can you please give the font
There's one?
of the size of the terminal,
I can try.
because it's hard to see.
Right. Let me see. I don't know where I do it, but I think.
In view on menu bar.
Maybe just Control+.
Oh, there you go.
Does that work?
Give it one more for the people in the back. Yeah, thank you. Need more appreciation.
Are we good?
Yeah.
Okay. There's another package that I like to use for a couple more, and I'm guessing we're gonna have to install them. So there's one of them called Plot-A, and Plot-A allows you to make interactive graphs, like the kind that you would put on a dashboard. And so I'm gonna install packages, quotation marks, plot, ly, plot. And we'll run that. And once again, it's going to look for the package, it's going to look for where to download it, and it's probably going to download some dependencies that come with it. That was quicker. Yeah.
So are all these now being put into the folder that was created on the desktop?
They're saved under like R's folder. Yeah, the packages themselves, but they're basically in your version of R whenever you use it. We could get a couple more or one more that I think is useful. And so I'm going to install that. It's called GG themes. And so install packages and then parentheses, quotation marks, yeah.
Are there any environments? I mean, in Python there is a virtual environment where you can install whatever package in one version, and you can. I mean, it depends on. Is that the same applies?
Yeah, so you can do an R Studio on the cloud, but there are different ways of doing it. And you can have ones, you know, like for teaching, you could have a cloud environment, and you can do a lot of setting up stuff ahead of time. You can put in which packages are in there and so on. There is nothing similar. And so now, I mean, you know, I install packages once and then I have them forever, right? Most things that. And so again, we install tidyverse, we install Plot-A and GG themes. Questions? Really?
Yeah,
Yes.
it's all.
I think so.
haven't seen.
Yeah, it's just telling you something, but it's telling me that it was successfully unpacked and installed. So I think it's just telling you that if you wanted to build some stuff, you have to have R tools. Other questions?
I'm just curious, is there a place where they identify what the library has and what exactly these things are? How do you know?
Sure. So a lot of it is from experience, but yes, there is a website, and so let me open that. Where most of you downloaded your R Studio. I'm guessing. It's called CRAN. So you can pick up CRAN R. And this is the Comprehensive R Archive Network. So this is where you will download R. And they have a list of all the packages there. And so they tell you about packages that are no longer supported and so on, because this is, you know, a lot of people write these packages. And so, so yeah, you may have to kind of go out and find them, but this is the place to find them. Change my share. All right, any other questions? Okay, so why don't we start writing a script, since we want to be able to keep track of what we're doing. So we're going to go up to the top left, and there's a little green plot sign there. If you click on this, I'm going to choose an R script. When I do that, now my view kind of changes a little bit. It creates some space for my script, which right now is an empty script. It keeps my console down here. Where I can still go and do stuff interactively if I wanted to, if I want to test something. It's still going to keep my environment, and it's going to keep this other thing where I can see files. So far, so good. So the first thing I do on a script is load packages, right? I'm going to load the packages that I know I'm going to use in my session. Again, one of the beauties of this is that I could just load tidyverse, start working, and then, you know, 10 minutes later, I figure out I need Plot-A, then I can go back to the top and add it to my libraries. Yes?
Quickly, how did you get that open window on the top?
Sure. So you go to the left, top left of your screen, there's like a little green plus thing. And you hit that and it gives you a menu. And choose the first one that says R scripts. So a couple of other cool things. You know those instructions that I put on Canvas, that's an HTML file? I created that in R. How? You go into the stop thing and you choose a Quarto document. And the Quarto document will allow you to write Word documents, PDFs, HTML pages, electronic books. It gives you a bunch of options, right? So you can do a lot of really cool stuff. You can make dashboards from Quarto documents. So it gives you a lot of flexibility to create all sorts of output if you wanted to do that. And so we have our script. Everything was fine, right? And so I'm going to start by loading packages. And so I always load, as I said, tidyverse. I load Plot-A, so I'm pretty sure I'm going to use it. And I'm going to load GG themes. Okay. Now, when I'm writing these things, nothing is happening, right? Nothing at all. I'm just writing these things, hitting enter, And it's not like if I was here and I wrote 1 plus 1 and I hit enter, absolutely nothing happened, right? Or if I wrote X and assigned to it 1 plus 1 and I hit enter, nothing happens, right? Because the script doesn't get run until you tell it to run. Now, you can run one item at a time. If you stand on that item with your cursor and you hit Control, Enter. So in this case, I did that, and it told me library tidyverse, and you can see on the console that it did that. Now I can hit Control Enter again on this line, and that's going to tell me that it's running Plot-A. Now it told me some other stuff when it ran Plot-A. It told me about conflicts and maths, just like tidyverse did, and then I can do Control Enter again on library GG themes, and it's just telling me yes, I've run that command. So far so good. So by doing that, now I have everything I need. Questions? Yes.
I think error it says do not find function library in the console.
Yeah, so that's one thing. R makes a distinction between lowercase and uppercase. So I could create another variable, say capital X, and it's 1 plus 2. And if I do Control Enter, now I have 2 variables. I have lowercase x, uppercase x, right? 2 separate variables. So R doesn't think that those are the same thing, right? So you got to be careful and mindful if you're naming objects that you know whether you're capitalizing. Yes.
Mine didn't show up on the other side. Hold on.
Did you do Control Enter?
Oh, after the 1 plus 2?
Yeah.
No. There we go.
Right, because so remember, the script doesn't run itself, right? So when you're writing stuff, when you're writing a script, basically what you're doing is you're kind of writing a sequence of steps. And then normally what you will do when your program is ready, you will source your program. And that's going to run all the steps. But you can run one line at a time by kind of clicking on the line and hitting Control Enter. Or you could select a bunch of stuff and either hit Run or Control Enter, and that would run those steps. Yeah. And so if you're testing something, you may not want to reload your data and all that stuff. You may just want to run that one command, then you do that kind of thing.
Yeah, my x equals 2 disappeared. Is that because I did something wrong? Like my first value for x at the other is.
Oh, a lowercase x or uppercase x?
That's probably it.
So when you do it with a lowercase x, you replace your old
Replace my
variable.
other lowercase.
That's
Okay,
correct.
got it. Sorry.
Okay. Makes sense. All right, so I'm gonna put some notation, some notes here just so I know what I'm doing. So if you start a line with a hashtag, R knows that this is a comment. It's not something that is gonna be read. And so here I'm just gonna say load required packages. And so that way, when I'm opening this thing 2 months from now, I know exactly what I was doing here. Okay. Now let us get our data so we can actually start working. So I'm gonna put a note here that's gonna say load data. And again, because I have a hashtag in front of it, R is gonna ignore that when it reads it as a script to know that it's just a comment. So we have a data set, and so again, I want to point out, if you look, and for those of you that are online, or I'm hovering right now, right? This is telling me what directory I'm in. I'm in my directory or our workshop, right? If you did what I did, you have a folder in that directory called data. And that's where I placed my CSV file. And so I'm going to bring in that data set. And I'm going to use a tidyverse command called read CSV. Read underscore CSV. I have to tell you where it is. So open quotation marks. Data, which is the name of my folder that I'm going to go into. / And I think this is the name. And actually, you can actually hit tab. And it's going to show you options of things that are in that directory. So in my case, there was only one file. So when I hit tab, it loaded for me the name of the CSV file. If I had a bunch of files, when I hit tab, it's gonna give me a list, and I can choose the one that I want. So, a couple of things to point out. This is a tidyverse command, read_CSV. R has a read.csv command that in essence does the same thing. When you use read.csv, it's going to create what R calls a data frame. When you use read_CSV, it's going to create what R calls a table, which is basically just a data frame with some things that make it a little bit more functional for all the tidyverse stuff. So I always use this one. And if and they work a little bit different. So you want to be mindful of that when you're typing in your command, whether you're using read dot or read_CSV. Now, what's going to happen if I hit Control Enter now?
It's going to read
I'm going to read the data, and then what?
and it throws the output in the console.
Actually, it's going to show me the output in the console, and what can I do with it?
Not really, because we just said we are not storing that.
You haven't done anything that you can work with, right? So if I run this command by hitting, I'm standing here and I hit Control Enter, then it's going to load my data, and it's going to give me kind of a preview of the data, right? And I could lift the console a little bit, and it's going to tell me, right, that it wasn't sure about some stuff that it read, right? Some things giving us characters, something giving numeric, but it gives me a view of some of the rows, and it tells me you have 3 more variables and 19 more rows. So it gives me some sense of the data, right? But as one of you pointed out, I haven't stored that anywhere, right? I did not assign that to absolutely anything. As I said at the beginning, this is an object-oriented programming where we're going to have to create an object that stores the result of this command. So I'm going to create an object, and I'm going to call it MBS, which is main data set for me, just to remember, and alt minus, and I'm going to assign to MBS the result of that command. Okay, so I just went back to that command that I wrote, and I just put MBS in front of it, and then I hit alt minus. And what this is saying is create an object called MBS, assign to the object the output of this command, right? And so I'm going to run that command and assign it to MBS. So when I do that, Control Enter, now in my environment, I actually have a data set called MBS that has 29 observations of 12 variables. Okay. Now, one of the things, I was a big Excel user for many years. And one of the things that is really hard to do is to kind of detach yourself from viewing the data, right? The nice thing about working in Excel is that it's so visual. You see it right in front of you. If you modify something in the data, you can see how it changed, right? That's also a weakness, right? Is that it's so easy to do things and see them happening in front of you that you just do them, right? And then, like, you remember when Dan was going through stuff, if you're not careful about, like Dan was doing, naming every column. In this column, I did this. In this column, I did that, right? If you're not doing that, it's really, really hard to know how you went from what you started with to what you ended with, right? And so that's one of the things that I found very hard when I transitioned away from using Excel to using R or Stata, is that you're no longer looking at your data that often. You're doing things to your data without necessarily seeing it. Now, there are a couple of things you can do. One of them is you can actually look at the data. So if you go click on MBS in your environment, it's actually going to open a pane with your data. And so I can see it over here. I have my data set called MBS, and I can see the different variables there, and I can scroll down and I can see the different values for the data. Okay. Yes.
I'm behind, I need a little bit of back.
Sure. So where are you at?
So, for some reason, after I load data, I can't get the read CSV to pick up my all populated data.
Okay.
So I have a data file saved on my desktop. like he has to in the beginning, our workshop, data here, and all those things inside of the CS.
Oh.
Is that all?
That's a different file.
Oh, it's not the same from
It's
the,
not a CSV,
No,
like that.
and so, let me show you the URL again.
okay, let me
And
get
the
that,
later one.
that would be cool, okay. I think this was the one from the data.
Right, and I took that one and made some changes.
Sorry.
And again, when you download it, what's gonna happen is, it's gonna download as an Excel file, so you should open that.
And save it.
And then save it as a CSV file in the folder, and let me get that on the screen so you can see it also. You see it?
So.
Okay,
It's a good one.
let me file into. Download as a copy. Yes.
All right. And we'll get back to you, so.
Yeah,
so
that's
heads up. So there are a few other things you can do. I'm trying to remember the name of the function. I think it's glimpse. I can do a glimpse of the data. So I can call it glimpse MBS, right, which is the name of the object. So it's basically going to give me a view of what's in the file, and so it's showing me each column. It's giving me a few observations from each column, and it's telling me what kind of column it is. So you may remember from Excel that you can format as a particular form, right? Like you can format it as a date and so on. So this is telling me the first column is a character column, second one as well, third one as well. The fourth one, which is the duration in hours, or the number of hours that the movie has, it's a double, which is a numerical way of storing. So you can kind of get a sense of the data. The other thing is you can build some stuff in, right? So you may recall when we did the Excel one that there were, for example, some years that were coded a little bit off. And so I could, for example, put in, and this is something where you can do it in the console, you can do it in the program, get rid of it. So you can do minimum, and now I choose MBS, $, and I can see all the variables. And so I could go to release year. Right, so here I have minimum of, I tell it my data set is MBS, my column is release year. And if I run this command in my console, it is going to show me the lowest year is 1996. I can change that to a maximum, I can change it to an average, right? So I can write all these functions to basically quickly look at my data and get some sense of, right, in the original Excel file, I think one of these release years have like a 7, right? And so if I ran this function, minimum MPS release year, then what I get is a 7, I know there's a problem there. And that will tell me, well, you gotta fix this data, right? So there's a bunch of things you can do to kind of look at your data, not necessarily by looking at it, but by putting in the kind of things that you would want to do to make sure that your data matches what you're expecting. Any release year that doesn't look like something like this is a problem, right? And I would know that. So, so there's a lot of things you can do in that sense. Okay? But we're working with a clean data set, so I'm going to skip some of these things. Glimpse may be useful. I would probably run that in the console rather than in the program, because it's something that I'm going to do interactively just to get a sense of the data that I'm working on. Right? All right. Everyone has an MPS object that is a data frame with 29 observations and 12 variables. Is there anyone who has not gotten there? Are we all good?
No, yeah, I'm gonna use it here, but
Okay.
can I just come up with it?
Yeah, and you'll have the script, so you can build it. See it. Okay, so we're gonna build our first graph, and as you know, this data set is a data set of the number of times that, what's his name? That Owen Wilson says wow in movies, right? And so, how do we make a graph? We're gonna take our data set and we're gonna put a series of commands into it. Now, we could write a function called ggplot. Okay?
Yeah.
And within the ggplot, I would say data equals MDS. Okay? Now, that only knows that that's the data I want to use, the data set I want to use to make my graph. Now, it needs a little bit more information than that. And the way that you tell it what you want in your graph is through these things called aesthetics. So data MDS, comma, and if you want to keep your code clean, you can put in and you can hit enter and go to a new line. And in this case, we would say aesthetics. So AES is for aesthetics. And I would say X equals total wows, if I remember this correctly, in movie. So that's my X variable. Okay. So ggplot is, I have to tell it what data I want to use. I want to use MDS, which is my object. And the aesthetics I want to use are the X variable. Since I'm going to do a histogram, all I need is the X variable. And R is going to calculate the bins to make this histogram. Now, if I just run this, control enter at the end of this command, I'm going to get a graph that doesn't have anything, pretty much. It has an X-axis. It has some values, nothing else, right? Why? Because I didn't tell R what kind of graph I wanted to make. So by telling it that I wanted aesthetics X, all I told it is what I want for my X-axis. I didn't tell it what to do with that X-axis, okay? So I could go back to my command and I could add, so the way the ggplots work is you use a plus to add new things to it. And specifically for the graph you're going to make, you're going to use what is called a geom. So a geometric figure of some sort. And so in this case, I'm going to use a geom histogram. Okay. And so now I have ggplot, my data is MDS, my X variable is total wows in movie, and I'm going to add a histogram to that. I can run that. And now R automatically selects my bins for a histogram. So movies with probably very few wows are the largest group, and then movies with more wows, there are fewer of them, right? Now notice R tells me here, using bins equals 30, pick better values if you want to create your own custom, right? There may be times where you want your histogram to be more specific to something you're doing, and so you can customize options of that histogram. Questions? Now, one of the cool things about doing this in R is that I could have, before I added this histogram, right? I could have assigned this to an object. I'm going to call this F1 for figure 1, right? And if I run that, so F1 is ggplot data MDS, aesthetics X equals total loss in U. If I run that, nothing happens, but I do get an object in my environment called F1. Okay. If I run that object in my console, for example, if I go into my console and I type F1 and hit enter, then that graph, which at this point is not a histogram, appears there, right? Now, that's not a very useful graph. And so I can take F1 and I can add a geom histogram to it, right? And I can run this, and now I have a histogram. Furthermore, I could assign this to F1. So I can say, take F1, add a histogram to it, and assign that to F1. So I run that. Now, when I run F1 in my console, it actually pulls up that graph, right? So I can build my graph little by little by creating an object and then adding layers to that object, right? So as of now, F1 is this graph, right? My object called F1 is this graph. Now, there are some things that are not pretty about this graph, many of them. And so I can take this graph and I'm going to add to it. And I like leaving spacing between my plots, because you don't have to. I'm going to add labels. And so you do that by adding labs. Now, in this case, if you put an enter here, I kind of like to keep my code somewhat readable. And so in this case, I'm going to say x equals, and in quotation marks, I'm going to say total wows in movie, comma, and I'm going to specify for y, I want the variable to be called count. So I can take my F1 item and add those labels. And so now I have something that looks a little bit prettier. It tells me what I'm looking at, the count of total wows in movie. So a movie with 5 wows, there's about 3 of them, I guess. Now, still not perfect because I don't like the scaling down here, right? We know these are whole numbers. And so I'm going to add, and again, you can do this. You can keep making an object and adding to it, or you can just do it all at once. So here, I'm going to have the scale x continuous, and I want the breaks in my scale to go from 0 to 12. And so I can run that. And now I have something that is showing me it actually doesn't end up going up to 12 because 10 is the maximum. So it knows where to stop, right? And I can do the same for scale y continuous. And maybe I'll use the same place and I'll let it kind of decide from there, but at least it's formatting things a little bit nicer. Right, so now I have count, total wows in movie, much more nicely written, and I have some scales that make more sense to show, right? And then you may remember we loaded a package called GG themes, and GG themes allows you to use pre-built themes to make your graphs a little bit nicer. And so, let's say you're taking a class with Dan, and he wants you to do your graphs in Excel. Then you can go in here and look for theme Excel. So I can add theme Excel at the end, and then rerun this graph, and it's going to use something that looks like something that Excel would have produced. It's pretty neat. If, like me, you enjoy reading The Economist, then you could choose this theme Economist to make a graph that looks like it was on The Economist. And they have a bunch of cool themes like that you can kind of play around and change your graph. Questions? Does this all make sense? So, yeah.
Just on the x-axis, so those are each of the individual movies, right?
Well, so what it's doing, it's counting. I guess it's counting movies where he says wow once, and it's telling you there are 9 movies where that's the case. There are there are
Yeah, I forgot
6
we're working in it. Sorry.
Right, so there's 6 movies where he says wow 12 times and so on, right? So yeah, it's counting the number of times the movie has that variable, the number of wows. Now, once I'm happy with my graph, and a couple of cool things is that you could actually make a function to make a graph, and you could make this graph for all different kinds of variables. And so once you've made that function, all you do is you run that function with the new variable that makes a new graph. Now, in this case, I'm going to assign all of this to F1, right? And so I'm going to run this, and now my F1 object actually has that entire graph as I want, right? I can now save this graph, and you will do that using ggSave. That's the command for saving graphs. And so ggSave, and I would say plot equals F1. By default, it's going to choose the latest graph you've made. But so like if you made a bunch of graphs and now you want to save them, you can choose which one. And I would say file name, and I'll give it a name. And you may recall I have a folder called output. And in the folder, I'm going to call this figure1.png. And that way I know it's going to save it as a PNG file. You could specify some details. I could say I want the width of the graph to be 7. I want the height of that graph to be, I don't use 4. And I want the units for this to be inches. And that way I know the ratio on which is going to save my graph. And you can even specify, if it's not clear, you can specify device equals PNG. And that way it knows that what I'm saving is a PNG file. It's a little bit redundant, but I find being more complete rather than less complete a good thing. So there, it saved the file for me. And so in my directory now, if I go to output, I should have a PNG file that was created. Notice again that essentially I'm never touching the data, right? I have not modified the data in any way. I haven't done anything to the data. I fed it into R, and the CSV file is saved in its directory without ever being touched, right? Which is sort of the way you want it. You want to leave the file. The other cool thing, and let's see if this works. I know once you start customizing, it doesn't always work, but you could go ggplotly. I normally make my plot list kind of directly, but if you do ggplotly of that object, F1, and if you run that, now I have a graph that is an interactive graph where I can, scroll over the bars and it tells me something about it, right? Now, this is not the ideal way of making a plot list. If you actually wanted to make plot lists for, like, say, a dashboard, you'd probably build a plot from scratch the way like we do a ggplot. But it's an easy way to take a ggplot and turn it into an interactive thing if you wanted to put this like on an HTML file and you wanted people to be able to kind of play around, right? And then it gives you some cool features like you can zoom in on some section of the graph, and then you can scroll over and so on. So it's a very easy way to create a plotly file, right? You make a ggplot, and then you just ggplotly it. Again, I probably wouldn't go that way if that's what I was doing, but good to know. Right? And so over here, I'm gonna put some that says histogram, just so that I know that what I'm doing in the space here below is creating a histogram. And again, you probably want to work cleaner than I am and specify what the different steps are. But yeah, if you were working on a serious script, probably would be putting notes in different places. There's another way you can use one of those quarto files, and you can do the opposite. You can kind of write more text and then have boxes of code where you actually do your code. So if you were writing something that is not for somebody else to run your script, but for somebody else to understand what you did, you could write a document. It says here, I did this, I did that, and then you have the box of code for decommissions. Make sense? Questions so far? Yeah, I know that in all the things we've done, one graph I haven't seen anyone do yet is what we call a box and whiskers graph, which I like. Not everybody does. But, so let us do that. I'm going to show you another way of doing this stuff. You remember over here, I started with my ggplot command, right? I started with ggplot, and then I told it, here's the data I want to use. So R, and I think this was originally a tidyverse thing, but now it comes built in with R as well, has this thing that they call the pipe. basically what it allows you to do is to type a sequence of steps. And so I could say, I want to take the MDS data set. And in a PC, you will hit Control Shift and M at the same time. And it's going to give you this little thing that looks like a percent greater than percent thing. That is the pipe. And so I can now say ggplot. And what's happening is that what the pipe is doing, it is spelling ggplot, but the first argument of this function is this thing. And so when is this useful? This is useful if you wanted to, for example, take a data set, filter observations to a particular group, and then with those observations, put them into a ggplot. Because then what you could do is you could say, take MDS, filter based on this condition, now make a ggplot, right? So you can kind of build those steps in rather than having to create a new data set that is filtered and then making the ggplot from there. So the pipe is useful for that. And so I normally start my ggplots with a pipe. I say, here's the data. And now here I can say my aesthetics. And so in this case, I'm going to use as my X variable. I'm going to use a variable that I made up in the data set that is called ERA, ERA, which is basically just seeing if the movie is kind of early career, mid-career, or more recent. Okay. And I'm going to have as my Y variable, I'm going to have total whilst in movie. Now, one of the nice things about using the pipe is that once I use the pipe, when I go into my ggplot command, when I'm typing in variables, it's going to give me potential variables from my data set. So it knows I'm using this data set. Now it's going to, as I type things, it's going to show me the potential variables that start with total, right? And so I can just tap my way into that. Now, if I run this, much like before, I'm going to end up with a graph that has ERA, that's my x-axis, total whiles in movie as my y-axis, but it doesn't have anything, right? Because I have not given it the plot I want to make. I haven't told it what geometric feature I want for this graph. Make sense? Questions? Okay, so what I can do is I can add to this a geom box plot. Before I run this, how many of you know what a box plot is?
It's like we're dividing the plot into sections.
Not quite.
Like
Left quartile, right quartile, like
Yeah.
a whisker, like
Right.
you can
So,
see in canvas.
right. So this is like it's like a distribution graph. It tells you the lower quartile, top quartile, median, and it shows you the range, right? And so in this case, right, we can create a box plot in which for each era of movies, his early movies, his mid-career movies, and his recent movies, we can see what the the median, this will be the median right here. What's the median number of wows, right? And so he's certainly been increasing in the recent movies. Recent by my definition, right? I just made this up. But he's been increasing the median number of wows that he uses, right? So that's a box plot. You could add, you can add, I think this is kind of nice. Sometimes if you actually want to see the data around this, you could add another geom. In this case, I'm going to add a geom called jitter. And so now I actually have my my box plot, but I can also see where those points are. Now, what jitter does is that it moves those plots a little bit to the sides so that you can kind of see them. Otherwise, then they kind of fall on top of each other. By jittering them, you get them to move a little bit around. And so that can be a nice feature if you want to be able to see the distribution, which is what the box plot is showing you, but you also want to see kind of what the data looks like, right? It could be that this is driven by hundreds of observations and this is driven by like 5, right? And by doing the jitter on top of the geo of the box plot, you can actually see that, right? You can get more information about it. Yeah.
So the data looks like it's just kind of randomly scattered, but just to give you a sense, because like my dots, your dots.
Yes, so what genome jitter does is that it randomly jitters the data. And so it's kind of, rather than, aligning it up, it's kind of moving it a little bit around so you can see kind of where it is. So it's useful when you have things that may overlap a lot, and you kind of just want to be able to see them. You can use transparencies for the same reason, but the jitter just kind of moves them around. Other questions?
Is some of the dot outside that box kind of far away from it, kind of indication of making outliers?
Right, so when you get the whiskers that look very long on one end, yeah, you probably have some outliers up here that are just way out there. Right? This data set's really small, so, right? But yeah, certainly, normally you see kind of whiskers that are a little bit more normal. But yeah, sometimes the box plots are made without the outliers in the whiskers. They actually put the outliers out there, like as dots. All right, questions? Again, we can make an object out of this. We can save it, right? The same procedure as I had before. We can modify it, etc. So far, so good. Right. Let's make a scatter plot, which is often used. And again, I will put a file like this in the canvas page at some point. I'll probably clean it up a little bit before. So let's see. I created a variable called duration in seconds, which basically takes the hours, minutes, seconds, and just creates that as how many seconds long is the movie, just because it was easier to have a simple variable. So I can take, I'm going to create some space here. I'm going to take my data set, Ctrl-Shift-M, it's going to give me the pipe, and then I'm going to say ggplot aesthetics. For my X, I want duration in seconds. And for my Y, I want total Ys in. Okay. Now I make a scatter plot by using geo point. So point is what you would use to run a scatter plot. So I can run this. And now I have a scatter plot of total Ys in movies against how long the movie is, right? And so it turns out that he uses wow in some short movies, relatively speaking, right? These large numbers are in movies with shorter durations, not so much on the longer movies, right? Now, it could be that different types of movies and so on, but that will give you some pattern to look at. Questions so far? Let us build on this one a little bit. So we have our base scatter plot. One thing we can do is we can make the dots a little bit bigger. And so I indicated in the genome point that the size should be 2.5. And you can play around with this, right? Like you can run that and see what happens. In this case, we make some dots that are a little bit bigger. So you can choose, I don't know what 2.5 means, right? If 2.5 works for me, okay, then I'll go from there, right? Now we can add some labels. How do we do that? Labs. And so my X variable, I'm going to call, and I'll tell you what I'm doing here in a second. I'm going to put a /n. Because those two why I was telling you the backslashes are kind of the problem. Duration of film, and I'm going to put here total seconds. And then my Y is going to be total hours movie. I'm going to put a little /n in at the end. Now, when I run this, and I'm gonna tell you why I use this little /n piece. So now I have a little bit nicer labels to my axis. When I wrote this and I put this n/n, that's telling R, start a new line. And again, that's why backslashes in like your path become a problem, because R thinks that it's an escape character. That's what this slash is doing. So /n means new line. And so if I had a path to a folder that was called names, and I do data /names, it's thinking that I'm putting in a new line. And that's why we have to switch to forward slashes. But this basically is allowing this label to go down a little bit. I find that ggplot puts them too close to the axis. And so same thing here. Total was in movie, if I didn't put this in, I feel like this would be too close to the axis. And so I put in a new line. And that way it gives a little bit of space. And that's why I do that. Again, that's entirely a personal preference. Yeah.
So could you put the /n to the y? Would you put that in the title?
I can. And so it would basically create a little bit of space around that, right? In this case, I wanted that after the text, I wanted the space. Now by putting it in front, I also have some space before. Right? Questions? All right, let's fix the scales a little bit, right? They're not that pretty, and I may have to use a package that I don't know if I have installed. Let me try. So scale X continuous. Now in this case, I could say I want the breaks to be a sequence that goes from 4,500 to 7,500 by increments of 500. So I can tell it that I want it to go in that range, and so I can do that. And now I go something that goes in increments of 500 instead of whatever R shows automatically. I could also say I want labels, and I'm going to use a package called scales, and I want to see if I have it. I think I do. So scales. And so notice here, I didn't load the scales package, but I can call it by using scales colon, and then I want to use a function from the package that is called comma format. So if I run this now I have things that are comma formatted and look a little bit nicer than the other scales. And I can leave my scale y-axis just like we did before. I can put in breaks from 0 to 12. So this 0 to 12 notation is a quick way of saying a sequence from 0 to 12 that increments 1. If I wanted a sequence that changes in some other way, I have to use the sort of sequence function that I used. So now I have something that looks a little bit better. Does that make sense? Questions? Who's lost?
I'm very lost. This has to do with where I saved my filing.
Okay, but we can pick it up.
Yeah, I get where we're going. I just can't grab what the stuff is. So
Can you describe again one more time why you have the 2 colons in the label scale?
Right. So there's a package, a library called scales. I didn't load that library up here. So by doing this, I'm telling it use the scales library and use the comma format function from that library. If I had loaded it when I did my libraries and I had included the library scales, then the comma format function I could use without any of this. So I'm telling it, I want the labels to be formatted according to this function. The function is from this library, but because I didn't load the library at the top, I'm just calling the library. That's one way of sort of bring it. If you have a one-off function that you're going to use from the library, you could just call it that way instead of loading the library. And again, that may be relevant if you have libraries that have a lot of conflicting stuff, then you may not want to have all the libraries loaded. And That's what we do. Make sense? So, not the most informative graph, but we could make some tweaks to make it a little bit more interesting. So, where we're putting my aesthetics, right? I said I want X to be duration in seconds. I want Y to be the total watts in the movie. I could actually map another variable to some other aesthetic in the graph. And so one way we could do this is we could add a color. So I'm going to put comma. I'm going to just have some space so we can see what I'm doing. I'm going to map color to my era variable. So that way, each era of movies is going to get a different color, right? So now, if I run this, I have the total watts in movie according to the duration of the movie for early career movies. I have it for mid-career movies, and then in blue, I have it for more recent movies, right? So I can actually add a layer in there that allows you to see the data a little bit different. Now, in this case, I don't find this extremely helpful, right? I mean, I still don't see much pattern in the data, and I know that this has been pointed out in every one of these workshops, and I'll point that out too. We're just looking at patterns. We're not, making any causal claims to the data. But we could add another genome to this. We could add a genome smooth. And what I'm going to use in this case is a method called LM, which is just a linear model. Essentially, for those of you who have taken stats, you will recognize that as a regression. It's a regression line of data. Now, I'm going to do aesthetic color equals era for my genome smooth graph. And I'm also going to say standard errors false. So I don't want it to show standard errors around it. It's going to get too crowded, but I'll show you what it looks like. And so I could run this command. And now I have his early career, his use of WOW is pretty independent of how long the movie is. In his mid-careers, the longer the movie, the more wows he uses. In his more recent movies, as the movies get longer, he uses wow less, right? So you can overlay a regression line on this with the same colors as the data so that you can actually kind of break this into different areas. Does that make sense?
Yeah.
So it's pretty cool because all you're doing is you're adding another layer of this. And again, my advice is once I upload the file, open it and just go in and play with this stuff, right? Like, what would have happened if I didn't put this command in here? Likely, guessing, these three lines would be black because I would not be mapping the color of those lines to the era variable, right? And so you play around with those things and you kind of see what do I do differently with these graphs. Does that make sense? And I'll just show you real quick. If I had not said ST equals false, so ST is for standard error, and the default is for it to be true. So if I had run this with standard errors, it is going to show me the standard error around each one of those lines, right? Which again, in this case, is very crowded, so it may not be ideal, but in some cases, I mean, obviously if you're reporting statistical stuff, you probably want to show this, right? The other thing is you can go down to your console and type genome smooth and hit enter. And over here in your help, you're going to get a description of what the function does and all your options, right? And so the genome smooth mapping null, that means I don't have to have a variable there. It's just going to choose something. I may have to tell some things like the method and so on. It's going to choose one if I don't tell it one. So if I didn't say linear model, it probably uses a smoother of some sort. And so with any function, if you have questions, question mark, name of the function, and it's gonna give you this thing that tells you like all the options. It's gonna tell you which ones are required and which ones are optional. And if you scroll to the bottom, oftentimes they'll have some examples where they run some stuff, and you can run those examples and see if you're getting the same. Make sense? Questions? Okay. By the way, here are your packages. So if you ever wonder if you have a package, you can go look for it. You can instead of typing in library tidyverse, you can go over here and look for tidyverse and click on it. Obviously, if you're getting used to working in a kind of programmatic way with scripts, then clicking is not what you want. You want is to be able to write these things and then just run. Questions? Let's do one more, and I know that we're kind of close on time, but let's just do one more so we do a little bit of data transformation to do that. And so I'm going to make a bar graph over time. Okay. So I'm going to take my data set, MDS, some space here, and I'm going to group my data. So group by, and I want to group by release year. So I want to do something that is on an annual basis. So I'm going to group my data by release year. And that pipe, my next step. So remember, what this is doing is saying, take this data set, group it by release year. Now, once you've done that, the pipe is going to tell you, I'm going to make a new step that is using whatever happened here. Right? So I group my data by release year. Now I'm going to do another step with that data. And the step I'm going to do is I'm going to summarize. And what I want is, I'm going to call this top wows. And it is the sum of total wows in movie. So for every year, I'm going to add up how many wows in a movie, comma, I'm going to make another summary variable. I'm going to call it nubs for number of observations. And that's just equal to n as a function, which is just a counter of how many of those observations. So basically, it's going to count how many observations I have every year. Now, I normally, as a matter of practice, after I do something like this, I ungroup my data. Now, if when I did this step, if I had used a command called mutate to create a new variable, and I do this, then I ungroup. I end up with the data I had originally, plus some new columns that I created. When you use summarize, even after you ungroup it, you're going to end up with a new data set that is a summarized data set. And I'm going to run it just so you can see it on the screen. So what I end up with is a data set that has 3 columns. One is the release year, one is the total number of wows in that year, and one is the number of observations. So the number of movies, right? So in 1996, he had one movie which he said wow, and he said wow 3 times. Right? So this is creating a summarized data set format. Now, I can create a new variable here, and that's where I use this mutate command. And these are tidyverse commands. And I'm going to call this average wow per movie, and it's going to equal dot wows divided by number of observations. Okay, so I can run this again, so you can see what I have. Now I have 4 columns. Release year, total wows, number of observations, average wow per movie. Right? So I created a new variable that is calculated the average wow per movie. And now I can plot this, right? So from this, one more pipe. And now I say ggplot, aesthetic, X is going to be release year. And y is going to be this new variable I created, average wild per movie. Now, in this case, I want to make a genome bar, which is a bar graph. And I won't go into all the details to have it. You have the file and you can look it up. But the statistic I want to use is called identity. I basically just wanted to use whatever the variable already tells me. I'm going to tell it that I want it to be a navy color, and in a bar graph, that's not color, that's actually called fill. And so I'm going to call this navy. And I actually have a color variable that is the outline of the graph. And I'm going to use black for the outline of the graph. And so I can run this command. And I have a bar graph of the average wild per movie by release year, right? So in 1996, the average wild per movie was 1.5 because he had one movie in which he said wild 3 times. And so we have that for every single year. The outline is the black color that I pointed out. The navy is the fill of the bar, right? And so, again, what's different here is I use the pipe quite a bit, right? I took my data set. Notice that I didn't make a new object out of it, which you could, right? I could take MDS, I could group it by year, I could calculate these things and ungroup it and make that one object, right? I could call it like MDS by year or something. And then I could take that and do some stuff to it, right? I use the pipe, and I'm saying the way you read a pipe is actually and then, right? So I take MDS and then I group by release year. And then I summarize these variables, and then I ungroup it. And then I create a new variable called average wild per movie. And then I go into making a digit one. And then making it. Right? And so now we can do all the customization with the scales and the axis and all this other stuff. Makes sense? So, we made about 4 graphs. Hopefully those are useful to give you some ideas of the kind of graph you can make. If you end up going with R for Plot-A-Thon, I'd be happy to answer any questions you have as you prepare your playing data. If I want to learn more, shoot me an email. And again, I'll clean up my script a little bit, but once I load it onto Canvas and you have it, again, my recommendation is just go in and play around with it. You're not going to break anything, right? So feed in the data and start doing stuff with it and see, what happens if I change this, what happens if I change that, right? And that would be the best way to learn after all. Any questions? All right. Thank you, everyone.